Okay. So now we have that as an inequality, all right? And let's jump over and let's just do this next one as an inequality as well. So let's go ahead and take care of this one too. So here you can see we have an open circle above the -3 and a filled-in circle above the 2, which is slightly different. Here it was filled in, here it was filled in as well. So it's slightly different. So how's it going to change our inequality? Let's go to Stephanie, right? Okay. How would you write that inequality for this right here? Yeah, for this one right here. The inequality. So this right here. What number will we start with? Yeah, -3. And then what symbol will we put here? Okay, close. It's not the exact same though, because this one has a filled in dot, this one's open. Right, without the little equals to at the bottom. So this is the less than symbol. All right, and then X, right? And then what about the end here? The same symbol as before, right? Less than or equal to the 2, yeah. And I always get those symbols confused too, right? Because they look all the same to me. But this particular symbol, right, is less than. I would help myself remember it because it looks like an L, a little bit like an L. So less L for the less than there. Okay, so that's our inequality. But now let's talk about set notation. Again, if we look up here at their example for the set notation, you'll see the inequality, right? Inequality, there it is, repeated, right? Inequality, there it is repeated. Okay, inequality, there it is repeated. Okay, so it's the exact same thing. It's just having a little bit of extra written in front there. Okay, so for set notation, what we have to start off with is something called, I think this is called a brace, the fancy looking grouping symbol. Okay, like that. We'll put an X with like a vertical little bar there for X such that, and then we just recopy that inequality symbol. It's very easy. Just like that. Okay. So again, all you do is you just take that inequality and it just writes like that. Okay, it's the same inequality. Same thing here as well. We'll do the little brace, okay, and an X with a little bar like that. X such that. And now I'll just recopy this inequality here. So -3 less than X less than or equal to 2. Okay, just like so. Okay, so that one's super easy. I don't even know why we bother learning this one because it's almost identical to the inequality, but it's there, so I'm going to show it to you. Okay. Interval notation, though, that is a specific one that we definitely need to be comfortable with, okay, because it looks slightly different than the inequality. Let's go back up here again to our example where we had, okay, here was the inequality, and if you look, it translated to this. So if you notice what changed, all we have is just the starting point and the stopping point. We don't bother putting the X in there at all. So, same idea here. We have the starting point, -3, and the stopping point, 2, so comma 2, okay? And because we are equal to the -3, since we include the -3, we're going to put this special symbol. Okay, it's like a bracket, okay? A square bracket or just a bracket is fine there, whatever you want to say there. Same thing with the 2. Since it's equal to the 2, we include it, and so we're going to put a square bracket there. And that's how to describe that using interval notation. Okay. So then what will change for the interval notation for this second one here? Is it Musa? Yeah. Musa, how do we change it for here? What's going to be? It's still going to have the -3 and the 2, right? Because that's still our starting point and stopping point. What kind of symbol should I draw here? Should it still be the square bracket? Yeah. So if you look here, this one was equal to, but this one's not equal to. So in fact, we want to use the parenthesis there. Sorry. But the other side, yes, there you go, very good, square bracket. Okay, so here we're indicating don't include the -3, but do include every number then up to that 2 and including the 2. Okay, is that making some sense there? Any questions on any of that? All right, then what I would like you guys to do is turn the page. Okay, and we're going to look at these as well, okay? I'm not going to have you guys do these on your own either because, again, they're, not, well, these ones have arrows on them, so they don't always have the endpoints there. Okay. So here, all right, you'll notice we don't have a starting point and stopping point, necessarily. If we look at this inequality, Okay. How might we write the inequality for this graph right here? What might we write? Any volunteers? How might we write that inequality for that first graph there on the left? What do we say? Carlos, you got an idea? Okay, you're getting there. You're jumping ahead, though. Just what's the inequality? So we're starting at the 2. And if you notice, the arrow is going to the left, so that's less than or greater than? Less than, yes, less than. Less than or equal to, because we include the 2. And so it's going to be x is less than or equal to the 2 there. But you think you know the interval notation already? What would the interval notation be? Negative infinity up to 2. Yeah, great job. Very good. So, and again, exactly. The negative infinity, you can't ever, like the idea is, anytime you use an infinity in your interval, okay, it's always going to be a parenthesis. Because you can never get to infinity if you it just keeps going. But the 2 we can get to, and we do include it, so it's going to be like that. So very good. Okay, that's the idea. The only other thing we have to do is the set notation, but again, that's easy. If you have the inequality, you just write the x with the little bar there, and then x less than or equal to the 2. Just like that. Okay, it just repeats the inequality. Okay. All right. How about that second one there? Let's go to Jordan. What's the inequality for this one going to be? Very good. You didn't include the equal to, which is right, okay? It's an open circle, so we don't include the 2, and we're going to the greater than side of 2. So x is greater than 2. Beautiful. Again, the set notation, super easy. We just write that brace with the x in the bar there, and x is greater than 2, just like that. Okay. If you have trouble writing the brace and drawing it or whatever, you're frustrated. I had a teacher one time that kind of showed me something, and I'll put it up on the board because it's a bit easier. When it comes to drawing the brace, if you draw like an S, and then like the number 2, but stretched out a little bit, that's kind of how you can draw the brace. And then for the other side of the brace, you draw the 2, and then you draw the capital S. And there's the other side of the brace too. If you have trouble drawing those braces, that's one way to do it, but it's up to you. All right, so then can you give me the interval notation for this then, Jordan? Yes, now 2, comma, positive infinity, very good, because we're going off the positive infinity. What type of symbol should I put here? Should it be a parenthesis, or should it be like the bracket? Very good, they both be parentheses, because again, we're not including either one of those. Very good, well done. Excellent. So any questions on any of those? All right, so then let's look at this reflection here. This is kind of interesting. Consider the interval shown on the number line. It's the whole number line here. How can we represent this using interval notation? How can we represent that using interval notation? So, yep, what do you say? Yeah, Jacob, exactly right. Is that what you're going to say too there, Carlos? Exactly right. Negative infinity to infinity. And again, round parentheses, right? Okay. Now this is like kind of a silly question maybe, but what numbers are in this interval? What numbers are in this interval? Go ahead, Carlos. Yeah, all real numbers. Exactly right. That's another way to describe this, actually. All real numbers. Right. Yes. So if you want to be like really fancy with your mathematics here and real impressive, there is a symbol that we use to represent all real numbers, and I'll show it to you here real quick. I'm going to zoom in some so you can see it. So you draw a capital R, and then you just put another little line in it like that. Okay, so again, it's like a capital R, and you just draw another line right in there next to it, and that's the real numbers. Okay, so that's a symbol. Okay, there's other symbols too. For example, the integers, which are the positive, counting numbers like 1, 2, 3, 4, 5, 6, 7, and then the negative counting numbers, -1, -2, -3. The integer symbol is like a Z that's doubled up in the center like that, and then the rational numbers, which are like fractions. That's the Q, and I think it goes something like that. Okay, that's rational numbers. Okay, so anyway, we're all real numbers there. Okay. One other thing we're going to look at then, so that's how we describe these intervals. So let's look actually to describing some other things here called, end behavior. Okay, you guys hopefully remember that domain, right, describes the set of input values, or x, right, and the range is the set of output values, f of x, or the y values, either way you want to say it there. All right, so keep that in mind, right? Domain, I always remember it this way. Domain comes first alphabetically, x comes first, before the y, and then range comes second alphabetically, and so y comes second. So domain and x, range and y. We also want to be able to describe, though, what happens in the end behavior of a function. It describes, so what does the end behavior describe? It describes what happens to the f of x values or the y values as the x values either increase without bound, that means as we go really far to the right, approach positive infinity, or they decrease without bound. What happens as our x values go really far to the left? Okay? So, if we look at this graph right here, you guys already have an idea. What's going to happen to the graph of this as we move along it further and further and further to the right? What's the y value that we're going to approach here? As we go further and further and further to the right there, what's the y value that we're going to approach? Positive infinity. It's going to keep going up and up and up and up and up and up and up, right? It's going to keep going up, so positive infinity. As we go to the left along our graph, negative infinity. It's going to keep going down, right? Exactly right. And in fact, that's how we're going to show it up here. So, as the x value increase without bound, as x goes further and further to the right, the f of x values, the y values, also increase without bound. They go up to infinity. So a shorter way to write that is as x approaches positive infinity, f of x approaches positive infinity. Right? It's going to keep going up. Likewise, as the x values decrease without bound, so as we go further and further to the left is this way for you guys, right? Then they're going to decrease without bound. They're going to go down. So as x approaches negative infinity, f of x approaches negative infinity. Okay. So that's another idea here. So intervals we're going to use to describe domain and range, but they also have this idea to describe end behavior. So let's look at this picture right here. Okay, here we have a nice parabola. It's the graph of x squared. Okay. If you look here, they have the inequality. They have the domain described as an inequality, set notation, interval notation. Right? The domain is all the possible x values. Well, of course, this thing is going to go all the way to the right and all the way to the left, so it goes from negative infinity to infinity, right, for the inequality. And there's the set notation, same thing again. Remember, you see it repeated. And then interval notation, well, there it is, negative infinity to infinity. Okay? The range is described as well as an inequality. It's the y values, right? So now we're saying y is greater than or equal to 0 because it's going to go up from here, only up, no down, right? Set notation, again, it's just repeating that inequality. And then the interval notation, it starts at 0, right, includes 0, goes up to infinity. And then there's the end behavior. This is like maybe a newer thing for you guys right here. As x approaches positive infinity, so as our x values go further and further to the right, as you go further and further right on our graph, the function goes up to positive infinity. And as x goes further and further to the left, the function goes up and up and up and up in this case. So they both sides go to positive infinity. They both go up forever. Questions on any of that? Because we're about to do one here on our own. All okay with that domain and range stuff? All right, so let's take a look. Let's actually do one now, exactly how they want us to do it. So we can see here that we have this graph of the exponential function, f of x equals 2 to the x, shown. So this is a graph of 2 to the x. Okay? You'll see that we need to find the domain, we need to find the range, and we're also going to describe the end behavior. So let's focus on the domain first here. So as an inequality, okay, what does it look like the leftmost x value here is going to be? And let's go to Connor. So Connor, the leftmost x value here in our graph. Uh-oh, we may have lost him. Connor, buddy, wakey. Okay? I'll let you wake up some, but then we'll come back to you for a question, all right? So let's go to somebody else for right now. We're on page 7 there, Connor, looking at the domain and range of that graph, okay? Let's go back to Josh. Josh, what's the farthest left it looks like our graph is going to go here? Yeah, it looks like it goes -4, but then I see an arrow here at the end of that graph, which means it's going to go further left. So what does that mean? If it keeps just going left and left and left and left and left, what's it going to hit eventually? Exactly, it's going to go to negative infinity. Okay, and so that's where our domain is going to start. Negative infinity, because it keeps going to the left there. Okay, so oops, oh, sorry, you can't see it. There it is. Okay, and then what about Josh? What about to the right? Does it just keep going to the right? It looks like. Yeah. So now it's going to, yes, positive infinity. So we'll say less than x less than infinity, just like that. We just saw this idea of going from negative infinity to infinity. So you could say here, to describe this domain, you could describe it's all real numbers, right? You could just say all real numbers. Okay, just like that, all real numbers there. You could do it that way too. All right, so then set notation, well, that's pretty straightforward. Again, we'll just do the brace, the x, and then the bar there, and we'll just do negative infinity less than x less than infinity. And so then, Josh, what would our interval notation be? What would our interval notation be there, Josh? Okay, so let's just worry about the numbers. Where do we start? Where does the interval start? Negative infinity. And where does it end? Yeah, exactly right. And we can never include negative infinity or positive infinity, so it's got to be the parentheses. And that's all there is to it. Okay, that's all there is to it. Because again, you can never get to infinity, right? Infinity is its definition. It keeps going. Very good, Josh. That's exactly it. So does that make some sense to you now? Clear? Okay, very good. All right, let's try someone else here then. We'll go. Now we're looking at the range. So now we got to shift our thinking. We're talking about y values now. We're talking about y values. So let's go back to Connor. Connor, what's our range going to be here? What's our lowest y value it looks like we're going to maybe get to?
Y is greater or equal to 0.
Okay, very good. So I'm going to start here with 0. Okay, I'm going to put, and so actually, I mean, that's not wrong. I'll do that here. Let me do this part first. Now, it looks like we go to 0 here, but in truth, we will never actually reach 0. And I know that's hard to see with this graph, so I understand what you're saying, but I can tell you from the math, knowing math, the mathematics and stuff, you never actually hit 0 there, but it gets very close to 0. So, what's that? Yeah, exactly. It's like it's going to get so close that it's basically going to be 0, but we never actually get exactly to 0, so we're just going to leave that without the equal to. And now, make sure you use a y here, folks, because we're talking about range. And then we're going to go up to infinity. But what you said, Connor, was not wrong. You could just say, yeah, y is greater than 0. That's right. I would accept that too. Okay. So then for set notation, instead of starting with an x, right, we're talking about range. Range deals with y. So we're going to put that y in a bar. And again, we'll say 0 less than y less than infinity. And close that. Okay. Or if you want to do what Connor said to do, he's not wrong. You do y with the bar and just say y is greater than 0, because both of those things are describing accurately. All right. What about the interval notation then, Connor? What would that be? Where should our intervals start?
Parentheses 0.
Yep.
Comma infinity.
Perfect. Well done, sir. Exactly right. Yes. Okay, interval notation, again, it starts at 0. We don't include the 0, right? There's no equal to, so it's a parenthesis. It goes up to infinity. Again, you never include infinity, so it's a parenthesis. Beautiful. Okay, well done. So let's try another one here. Let's keep going. Okay. So, here's this end behavior idea. So now for this end behavior, we're describing as x approaches positive infinity. That means as we go further and further and further and further to the right, as x approaches positive infinity, f of x is going to approach, and then what? Andrew, what would you say here? As x approaching infinity, as our graph goes further and further and further to the right, what's happening to the value of our function? It's approaching what? It's positive infinity as well. Very good. Yes, it keeps going up, right? Keeps going up and up and up and up and up. What about as x approaches negative infinity, though, Andrew? What's our y values approaching? As we go further and further to the left, this way. I gotta get that right. Okay, as we go further and further to the left, as we go further and further this way, what's the value of our function approaching? 0. Yeah, it's approaching 0. Right, folks? As you can see here along the graph, As we go further and further left, it's getting closer and closer and closer to 0. Does it ever get to 0? No, but it approaches it. It gets closer and closer. Okay? And that idea of approaching is called a limit. That's actually something from calculus. So you're kind of doing like a little bit of like a pre-calculus idea right here. You analyze that in behavior. Okay. Questions on any of this? All right. So I would like you all to try number 6 then. Okay, number 6 on the next page, please. Okay, I'd like to try number 6 on the next page. So if you read the directions here, it's got several things going on. It wants you to write the domain and the range of the function as an inequality using set notation and using interval notation, and describe the end behavior of the function. So here, I'll kind of get you guys set up. So again, for the domain, I want you to write it as an inequality. I want you to write it as and set notation. And I want you to write it in interval notation. Okay, and then same thing for the range. I want you to write it as an inequality. Set notation. And interval notation. Okay, yeah, if you need to refer back to your the previous problems there, feel free to. And then, of course, there's the end behavior. And so I'll get you started with that, too. As x approaches positive infinity, f of x approaches, and then I'll put a blank there for you. And then as x approaches negative infinity, f of x approaches, and then I'll put a blank there for you as well. Okay, so go ahead and take care of those. Number 6. And I'll kind of come around and help you as necessary, too. Okay, and I'll be happy to check if you're not sure about it. Wait, no, you had it right. That's where it started. You had it right. That's right. It starts negative infinity. Because if you look here, again, the domain deals with all the possible x values. This thing's going to keep going left and left and left and left, so it's going to keep going to negative infinity this way. As you go to the right, it's going to keep going right. So it's going to be negative infinity, less than x, less than positive. So then, set notation for that. Perfect. Okay, so now try to range. Now the range is a bit different. Range deals with y values. So what's the lowest y value that we're going to hit? Yes. So and then up to 0. And do we include the 0? Does it actually get to y equals 0? It will. It does actually do it. It's hard to see in the graph, but yeah. Okay. You all right? You're like 30 seconds are here, and then we'll go over this one, okay? Let's go to Eve. Eve, if you don't mind here, your inequality for the domain of this guy. What'd you get? Negative infinity, yeah. Okay, just the less than, X. Yes, great job, exactly right. It goes all the way to the left, all the way to the right. Okay, the set notation, I'll just go ahead and draw that because it's a pain. Oh man, I already messed it up. Oh boy, this is going to get worse before it gets better. There we go. Okay. Like that. So it's basically just repeating the negative infinity less than x less than infinity there with just the x with the bar and the braces. And then interval notation, what would that be? The interval notation. Yep, just like that. You got it. Yeah, that's it. Good job. Well done. Thank you. All right. Well, let's go to Amanda. Range, please. What'd you get for the inequality for the range?
0 is greater than 1.
Okay, so let's see, 0. Yes, that would work. I'm going to flip it around though and just say y is less than or equal to 0. I do think we should put an equals to in there, but I think what you said is not wrong. You said 0 is greater than y like that. Yeah, and so we do want to include the 0, and then again, I just flipped it around there to make it y less or equal to 0. But that's saying the same thing. If you flip the entire inequality around like that, and with even the inequality symbol still, point in the opposite direction then too, that's correct. Did anyone write something slightly different for the inequality there and want to check it? Okay, because you could also have done negative infinity less than y less than or equal to 0 there too. You could do it that way as well. So either one of those ways is acceptable. All right, so in the set notation, again, no surprises there, y such that, and then you can just put, the y less than or equal to 0 in there if you want, or you can put the negative infinity less than y less than or equal to 0 there too. Okay, good. And so then, what about that interval notation?
0 and negative infinity, but you have to put.
Right. So you're saying 0, negative infinity like that, and then include the 0, but don't include the infinity? Okay, so yes with a but. The problem here is that interval notation always has to start with a lower number and then go to the higher number. So you see what yours is, it's backwards. We want to start with a negative infinity and then go up to the 0. Because it's like reading the number line from left to right. So we want to start with a negative infinity and then up to the 0 and include that 0, just like that. Okay, so not this, but that. Okay. So in numeric order, left to right. Okay, great. All right, let's go to, let's see here. AJ again. So AJ, how about this end behavior? As x approaches positive infinity, what's happening to our function value here? As our x values go further and further right, what's happening to the value of the function? So it's going down, so it wouldn't be increasing, it would be decreasing. So what value is it going to? What's f of x approaching? If it keeps going down and down and down and down and down, it's going to... No, it's going down below 0 though now. It's going even further down. There you go, negative infinity. Okay? And then as x approaches negative infinity, so as we go further and further left, what's our function approaching? It's still going down and down and down and down. So negative infinity again, exactly right. Okay. So you'll see all different kinds of combinations here. Okay. Sometimes as you go to the right, it's going to go up. The function will go up to positive infinity. Sometimes it'll go down to negative infinity. As you go to the left, sometimes it'll go up to positive infinity, down to negative infinity, and sometimes it'll go to a number too. Okay. So, all right, very good there, very good. Questions on any of that? Because that was a lot. That's a lot to get through. All right. Let's keep going here then. So explain 2 has us graphing a linear function on a restricted domain. So right, when you're restricted for something, that means you're limited, right? You don't have, it's not so the domain is not all x values. A restricted domain would be only particular x values that we're going to be graphing this thing. Okay? So unless otherwise stated, a function is assumed to have a domain consisting of all real numbers for which the function is defined. So in other words, basically, if you have a function, you just assume that the domain for that function is all the numbers that work inside that function, all the x values that work in that function. Many functions, such as linear, quadratic, and exponential functions, are defined all real numbers. So their domain, when written in interval notation, is negative infinity to infinity, or another way to write that is real numbers like that. You can see like that symbol there. Okay. Sometimes a function may have a restricted domain. If the rule for a function and its restricted domain are given, you can draw its graph and then identify its range. So for example here, for the given function and domain, draw the graph and identify the range using the same notation as the given domain. So if you look here, we've got a function, okay? And this function, what do we know its graph will be? Anybody? What's the graph of f of x equals 3/4 x plus 2? What will that be? What will it look like? That's a graph. Its graph will be a what? Well, yeah, Carlos? Well, so if it's a parabola, it would have a square, right? So no squares. What's this graph going to be? It's just 3/4 x plus 2. Connor, what do you say? It's going to be a line. It's going to be a line. It's a line. It's a linear equation, right? In fact, it's in slope-intercept form. 3/4 is the slope, 2 is the y-intercept. Okay? But it would be a line, but it's got a restricted domain here. We're only going for x values between -4 and 4. So how can we graph this, but not for the entire line, just from -4 to 4? Look at what it asks us to do. Since f of x equals 3/4 x plus 2 is a linear function, a straight line, the graph is going to be a line segment, right? Just a piece of that line. You can see it right here. With endpoints at -4, f of -4, or -4, -1, and 4, f of 4, or 4, 5. The endpoints are included in the graph, and so there it is. So what they have us do is, rather than graphing the whole thing, we just plug -4 in the first point, plug -4 in for x, and solve for the matching y value, and then plug the right endpoint in, the 4, in for x, and then solve for that matching y value, and get your points. And so then you just connect the dots. There they are. And of course that also limits the range then. You can see the range, right, it says is -1 to 5. You see there, the range is -1 to 5. That's because it goes from that up to the 5 there, -1 up to 5. Okay, so let's try this. Let's look at B. So B, we've got a function here, -x minus 2. And again, what will its graph be? What's the graph of this going to be? What will it look like? Anybody? -x minus 2, what's that going to look like? I'll give you a hint. It's in slope-intercept form, so that means it's going to be a graph of a what? A line, yeah, exactly. And we're going to use this as our domain. So this is in set notation, okay? If you look here, it's all the x's such that x is greater than -3, okay? So we want to find the starting point of this line. And so we're going to start with -3 because it's all x values greater than -3. So I'm going to plug in -3 here. So f of -3, okay? Again, because we're starting, our x values started at -3. Okay? X values start at -3 and it's all the x values greater than that -3. So plug in -3 here. So it'll be -3 minus 2. Okay, right? That -3 substitutes in for the x. So it's -x. -3 minus 2. And we simplify. -3 is a +3, take away 2, which is then just 1. So we have the point, -3, 1. Okay, -3, 1. And so we'll plot that over here. -3, 1. Now, when I go to draw this, what kind of point should I draw? Should it be open? Why should it be open? Sorry, who was it? Ah, Andrew. Okay, sorry. I was like, I heard a voice. So yes, open, Andrew. That's right, because it's not equal to here. You see that? There's not equal to at -3. So we're going to put an open circle at that -3, 1. Open circle there. All right, and then we need to come up with one more point. What's another x value that we can plug in? What's another x value that we can plug in here, based on our domain? What's an x value that we are allowed to plug in here? Can we plug in -10? No, -10 is not greater than -3. So what's an x value we can plug in? -2, 1, 0. Anything that's greater than -3, you can plug it in. Now, I would suggest you pick x values that are, kind of here. Let's do 0. 0 is an easy one. Let's do f of 0. And so it'll be -0 minus 2. -0 is still 0. So it's 0 minus 2, which is -2. So we have the point 0, -2. So 0, -2. Now, should I draw an open circle here, or should I draw fill it in like a dot here? Should it be open or filled in? What do we think here? So it was open before because x could not equal -3, right? It was not x greater than or equal to -3. It was just x greater than -3. But now I am at an x value that is greater than -3. We do want to fill it in. We do want to fill it in because this is an actual point that we're allowed to use. It's an x value that is greater than -3, so we can use it. So it's 0, -2, fill in the dot. Okay. Now, we're going to connect these. And then keep going and draw an arrow. Why do I draw an arrow here where in the previous example they didn't draw an arrow? Well, look at our inequality here. There's no upper limit, right? It's just x is greater than -3. So that means it just keeps going greater than -3. It just keeps going. Over here in the previous example, the domain was between -4 and 4. So it had to stop at the x value of -4, or start at the x value of -4, but then stop at the x value of +4. Okay? But here it starts at -3 and just keeps going. All right? Let's do one more like that, I think. We'll see how that... Yeah, we'll do one more like that, because that was kind of funky. Okay? So let's look at number 9 here. Okay, let's look at number 9. We'll do this one together here. So here our function is -1/2 x plus 2, and our domain is -6 less than or equal to x less than 2. Okay? So you can see here our domain has a starting point and a stopping point. So the first thing we should do is f of what value? What should we do? Where should we start here? Less than 2, but greater than or equal to -6. Now, I would say let's start with the -6, right? Because that's the lowest we can possibly go. That'll be our starting point. So let's just plug in -6 there. So that's -1/2 times -6 plus 2, right? Just plug the -6 in for the x. And we'll multiply here. That gives us a +3, which is then 5. And so we have a point, -6, 5. No. Oh my gosh, that is the bell, isn't it? I'm sorry, guys. I was way off. I apologize. All right, well, we'll finish this tomorrow. I apologize for that. What's that? What's that? Yeah, I'm sorry about that, folks. Yeah, I'm not going to give you any homework. I apologize. We'll finish this up tomorrow.